This discussion is about rectilinear motion. In BTech first year course, there is one subject, engineering mechanics. And you know that in engineering mechanics, there are basically two parts. First is statics and second one is dynamics. And from the chapter of dynamics, the first one is rectilinear motion. I think from class 9, you have started using three equations of three algebraic equations to find out displacement, velocity, acceleration, etc. Those equations are V is equal to U plus AT. V is final velocity, U is initial velocity, A is the acceleration or retardation. When A is acceleration, it is taken to be positive, and when A is negative, retardation, then it is negative, and T is time, small t is used. Next one is S is equal to, S means S or X, okay, both are used. Say we are writing here, say S for south, S is equal to ut plus half at square. Here again, U is initial velocity, T is time, and plus half at square. Here again, A is acceleration or retardation. Again, it is positive when it is acceleration and negative when it is retardation, and T is time. And using these two equations, the third one can be derived. That means the third one is not independent equation. Okay. Out of these three, only two equations are independent to each other. So third one is V square is equal to U square plus 2 into A into S. In the left hand side, V square. V is final velocity, square of the final velocity. And in the right hand side, U square, square of the initial velocity plus 2 into A into S. A is again here acceleration or retardation, S is displacement. All these things are known to you, but the problem is that I observed that many of the students make one mistake. In all these three equations, A is acceleration and retardation, there is no doubt. But here A is a constant quantity, it is not a variable. Sometimes problems are given like this: acceleration A is equal to, say, t square minus 2t plus 1. Means A is acceleration or retardation is given as a function of time. Again, this acceleration or retardation may be given in terms of displacement. Okay. That means what I want to say here, that when acceleration or retardation is not a constant, it depends upon something. Means it is a variable. It is no more a constant, it is a variable. It depends upon time or displacement or anything else. Okay. So when acceleration or retardation is a variable, in that case you cannot use all these three equations. That is, V is equal to U plus AT, S is equal to UT plus half AT square, V square is equal to U square plus 2S. All these three equations cannot be used when acceleration or retardation is a variable. In that case, you have to use the very basic definition of acceleration, very basic definition of velocity, like that. What is the very basic definition of acceleration? It is rate of change of velocity with respect to time. Rate of change of velocity with respect to time. At time t, what is the velocity? It is v. So it is written as, acceleration is written as, acceleration is equal to dv dt. dv divided by dt. dv dt. Okay. Say for example here, again we are taking that example, A is given as t square minus 2t plus 1. So first you write A is equal to dv dt, then in the left hand side instead of A you write t square minus 2t plus 1. So what is the result? dv dt is equal to t square minus 2t plus 1. Therefore, dv in the left hand side, write this thing in the left hand side, dv is equal to, in the right hand side you write t square within bracket, t square minus 2t plus 1 outside the bracket dt. And now integrate both sides. So in the left hand side you will get v, and in the right hand side you will get a function of t. First one was t square, so you will get t cube by 3 like that. Okay. And at the end you will get one constant. Say that constant is denoted by c or c1 like that. Okay. Now by using the initial condition or any other condition, at this value of time velocity was this much. This type of conditions are normally given for such type of problems. At this time the velocity was this much, or if it is mentioned that initial velocity was this much, say initial velocity was 50 meter per second, 50. Initial velocity was 50 meter per second. So in that case, you have to write when initial velocity, that means when time was 0. So you write t is equal to 0 and v is equal to this much, that is 50 meter per second. So using this condition, you can evaluate the value of the constant of integration, and you now know the velocity as a function of time. When velocity is known as a function of time, in that case, you can easily calculate velocity at any given time. Using this relationship between velocity and time, you can calculate displacement at a given time also. So instead of writing v, which appears in the left hand side, you write, instead of v, you write ds dt. ds divided by dt. So ds dt is equal to right hand side, which is a function of time. Then ds is equal to the right hand side multiplied by dt. Then integrate both sides. So in the left hand side you will get s, that is the displacement, and in the right hand side you will get a function of t, and again one more constant which is called constant of integration. Say it is denoted by now c2. Okay. Now here again, for this case also, some condition will be given. At this much of time, displacement was this much. Or again, if it is mentioned that the displacement was started from the origin. Displacement was started from the origin. That means when t was 0, that is the time was 0, displacement was 0. Okay. So using this condition, you can evaluate, you can get the expression for displacement as a function of time. Okay. So this way you can approach to solve for displacement or velocity when acceleration or velocity are given as function of something. Means when these are not constant. So in these cases, when velocity, acceleration is not a constant, in all these cases, you can notice v is equal to u plus at, or v square is equal to u square plus 2s, or s is equal to ut plus half at square. Many students make such mistakes. When time is given, displacement is this much. What normally students do? Say time is given. Acceleration is given. Acceleration is equal to t square minus 2t plus 1. And it is asked that calculate velocity at time is equal to 5 seconds. So what students do, I have seen what students do. Many students do this thing. Time is 5. So acceleration is how much? It is t square minus 2t plus 1. That is 5 square minus 2 into 5 plus 1. 25 minus 10 plus 1. 26 minus 10, that is 16 meter per second square. Now, say you have to calculate velocity. So v is equal to u plus at, and in that expression, for velocity, students do what they do. They write value of u in the right hand side. Then a is equal to that 16 meter per second square, and then the given time. And this is absolutely wrong. This is absolutely wrong. Okay. Just keep in your mind that whenever acceleration or retardation is constant, in only that case you use all those three equations. Otherwise, you have to start from the very basic definition of velocity, acceleration, etc. Right? Okay. Thank you. So this was a discussion on dynamics, or it's better to say it was a discussion on rectilinear motion. Rectilinear motion means what? Rectilinear motion means motion along a straight line, not along curved line. Motion along a straight line. Okay, thank you.